I held this up and asked you how many dots are on that piece of paper. You know, it would be difficult to get at first. Probably you would want to count them. But what numbers you write on paper to record your answer might depend on how many fingers you have. If you only have 3 fingers, how would you write the number? To keep track of what we're doing, we're going to start grouping by tens. We find that we can come up with 23 groups of 10, with 4 remaining. Now the question is, what next? Let's try grouping by tens again. So now we have 2 groups of 100, 3 groups of 10, and 4 remaining. Our final conclusion is that this number is 234. But supposing we group by fives, we find we get 46 groups of 5 plus 4 remaining in this diagram. It's the same number of dots, but we're grouping in a different way. Primitive peoples have often chosen base 5. Now if we group by fives again, we get 9 groups of 25, 1 group of 5, and 4 remaining. The configuration's a little bit different now. Lastly, we find that we can group 5 groups of 25 to 125, so we end up with 1 group of 125, 4 groups of 25, and 1 group of 5, plus that 4 remaining. Well, now our number looks like this: 1, 4, 1, 4, and we say base 5. Let's look at this a different way. Suppose we're making change, and we label each tray part in 10 times larger than the one next to it. So with our number that we've just looked at, we could write this as 2 100s, 3 10s, and 4 1s. If we group in fives, it would be 1 group of 125, 4 groups of 25, 1 group of 5, and 4 1s. So these two represent the same number, but they look entirely different. Our book shows us a different way of converting. 234 in base 10 can be converted by successive divisions by 5. The remainders taken in the reverse order also form 1 4 1 4 base 5. We can expand 1 4 1 4 base 5 back to base 10 by writing it in expanded notation. Here we have 125 plus 100 plus 5 plus 4. Now let's see how the TI-83 program BASECON can do these operations. Load the program and open to the main screen, and from there we want to choose option 3 to enter a base 10 number. Pressing option 3, we enter the number 234. We're going to enter a new base. Go to option 4 and enter in a new base. We're going to use base 5 here. Now press option 4 and the program will convert 234 to base 5. You see it's 1414 in base 5. Now we're going to convert 234 to base 2. We're going to find out what that looks like. So we convert to base 2, and the number is 111011010. Now let's change a number from base 9, and we're going to enter the number 6748. We're going to change it to another base, so we go down to option number 4, and we're going to enter in base 4 and see what it looks like. We do convert number 1, and we find out that the number is 1031321. What if someday NASA or SETI should start receiving a data stream made up of zeros and ones and twos? Would this tell you anything about the creatures at the other end of the data stream?